So, just how simple is it to design a wireless data net system? Well, let's see what Joe's up to. Joe likes to garden, so he spends a lot of time there. For irrigation, Joe had a water pipe that's connected to the city water system, ran from his house to the garden. To offset the cost of irrigating, Joe had a rainwater harvesting system installed. The collection tank was located where the water pipe is connected to the city water system, and an open-close valves were added so Joe could select which water source he wanted to use. After a while, Joe realized he was making a bunch of trips back and forth between the garden and the house just to operate the valves. He then thought, it would sure be nice if I could operate the valves from the garden. He considered his options. He could dig a trench, run conduit, and pull cables, but that would be expensive and he would have to dig up his blue ribbon yard. His other option was using radios, but since he's not technical, he was concerned the project would be too much for him to handle. But a friend told him about the new AGM wireless data net system and how easy it is to use. This is what Joe was looking for. So Joe set out to design his first wireless data interconnect project. Using the DataNet System Designer app, Joe enters Joe's Place as the name of his first project. That brings him to the Data Manager page. Here he enters where the data is and where he wants it to go. At the top of the page, he enters where and what data he wants to send elsewhere. So he enters garden as the origin. Then he enters the data. Since he wants to control the valves from the garden, he first adds city valve open close and rain valve open close. In both cases, he selects D as the data type. Now that Joe has entered where the data is, he enters where the data will go. He enters valves as the destination. Next, he selects valves destination and the city valve open close from the add data section. When he does this, a select type of destination menu pops up. Since he will be controlling a valve, he selects replicate. He does the same thing for rain valve open close. Joe has just designed his first wireless data net system and is so amazed and excited that he decides to expand it. Often he finds himself in the garden well after dusk and wishes to turn on the patio light from the garden. Since he also spends a lot of time in his man cave, he would like to be able to view the tank level there as well. So, at the top of the page, Joe selects garden, then adds patio light on-off data as he did before for the valves. Then, since he wants to display the tank level in his man cave, he adds valves as another origin. The designer will automatically detect that the valves location already exists and will use that location. For the data, he enters tank level, and at this time, he selects A since the data represents a range rather than an on-off state. At the bottom of the page, Joe enters patio as another destination and selects patio light on-off from the data list. Next, Joe enters man cave as another destination, and this time when he selects tank level, he selects show on display from the type of destination menu pop-up. To view a summary where the data is and where it's going, Joe selects DataNet Summary page. Here he sees there are 3 pieces of data being transferred from the garden and 1 from the valves location. The 2 garden valves open close are going to the valves location and the patio light on off is going to the patio location. Also, the valves tank level is going to the man cave. Next, Joe selects the Location Manager page. Here Joe will be able to create a layout depicting where the data locations are relative to each other. This helps Joe visualize his new project and will also allow Joe to make adjustments to ensure that all locations are in range of each other. This page includes a grid for drawing objects, a list of locations, and location options. Joe first draws a simple diagram of his yard showing the relative positions of the house, patio, valves, and garden. Joe then drags the garden from the list into the grid next to the garden he previously drew. Since Joe does not have any electrical power in his garden, he selects the battery-powered option. Next, Joe drags the valves location from the list in the grid and places it near the valves he drew earlier. As you may have noticed, when the two locations were dragged onto the grid, the locations were surrounded by a blue and red circle. The circles represent an estimated range of the DataNet modules. As long as the circle overlaps at least one other circle that is not red, the DataNet modules will be within range for communicating. Joe sees he might have a problem with the garden location since the circles are not overlapping. Rather than worrying about it at this time, Joe decides to continue to place other locations on the grid. After placing the other locations on the grid, Joe sees that 3 of the other 4 circles do overlap, so he's good to go. Even though the garden and the valves cannot communicate directly, the 2 modules will communicate through the other modules in the system. In the case of this example, there are 3 modules that the garden can use to communicate with the valves. If the modules that the garden is using to reach the valves fails, the system will automatically redirect the data through the other modules. Well, that's all there is to designing a wireless DataNet system. What could possibly be easier?